We have a very common misunderstanding about exponent in mathematics, which says if 1 raised to the power 0 is equals to 1 and 1 raised to the power 1 is also equals to 1, then we can say that 0 equals to 1. Since the bases are the same, the exponent must be the same, right? So 1 equals to 0. I mean, this condition, this equation is not true at all. And to prove that, we are going to take an example, which is b to the power x equals to b to the power y. Now, we are going to divide b to the power y to the both side of the equation. This whole thing becomes b to the power x minus y equals to 1. I've used a property right here, which is b to the power x over b to the power y equals to b to the power x minus y. And now we are going to take log to the both side of the equation. So this becomes x minus y multiplied by log b equals to log 1, right? Now, for this to happen, log 1, we have b to the power 0 equals to 1, right? Now, if anything raised to the power 0 is equals to 1, then this should be equals to 0, right? Then log 1 is going to be 0. And I've used a property of logarithm in this expression, which is a power property of the logarithm, which says log base b e raised to the power x. Then we can take x out of the logarithm and we can just multiply and write x multiplied by logarithm of a at base b, right? So now for this expression, x minus y multiplied by log b to be equals to 0, we need to have any of these two terms equal to 0, right? If any of these two become 0, then we will have this whole expression equals to 0. And to happen, we need x equals to y or b equals to 1. Then only this whole expression can be 0, right? So in this particular case, we have b equals to 1, right? That's why it does not matter if x is equals to y or not. If one condition is true, then we don't need another one to be true, right? And that is what's happening in this case. The exponents are not equal. As base is equals to 1, I mean, the b in this case is equals to 1. That's why the exponent are equal or not, that does not matter in this specific case. And that is how this equation is true.